Hello guys, welcome to my channel. This is Java Data Structures and Algorithms course, and today's tutorial is about implementation of a sorted set using a linked list. If you have not already subscribed to my channel, please subscribe and promote the content. Thank you. Introduction of set data structure. Set is a linear data structure. Set stores unique elements of the same data type. Set can be implemented using an array or a linked list. Array can be fixed array size, or we can use a dynamic array that will grow its size or resize it itself whenever it requires more memory. Sorted set maintains ascending order of its elements. All the elements must be unique and they are in ascending order. Set contains special functions, for example, union, intersection, difference of sets, complement of a set, disjoint sets, and proper subsets. These functions are not available in other data structures, so these are special for the sets. Time complexity, insertion. Because set can be implemented using different data structures behind the scenes. So if we implement array based data structure, so it will have a best case O1, and O1 happens if the set is empty. Then we have average and worst case scenario. Linked list based set has O1 when the set is empty, On when the insertion is carried out at the end of the set. So we have to navigate to the end of the set and insert the new element. We can achieve O1 runtime for insertion at the end if we add another instance field to keep track of the tail node within the set. So we can use that tail node and insert instantly at the end of the set, and we can achieve O1 runtime. It all depends on the design pattern that you will adopt to implement the set. In the case of insertion into a sorted set, the runtime complexity will be O(n) square, because you always have to navigate in the array, locate a location, and then have to shift the elements towards right to make a hole within the array and then insert the new element there. So O(n) is the complexity for searching for the correct location, and O(n) again we have to shift the elements, so it will become O(n) square. Runtime for the average and the worst case of insertion within the array, sorted array. In case of sorted linked set, this insertion will be carried out within O(n) time, where n is the number of elements we have to search to locate a correct location to insert the new element. Same way, if we are implementing set using an array, the deletion will be O1 in case the set has single element and removed from the front of the set. Otherwise, if this is not the case, the complexity will be O(n) for average and worst case scenarios, because we have to shift the elements to fill the hole created by removing the elements from the underlying array. In the same case for linked list. If we implement set using a linked list, the runtime is O(n) if the element is removed from the front of the set. In case of average and worst cases, they will happen when we have to search for the element. If element exists somewhere between the linked list, we have to iterate to locate and then remove the element, and its complexity is O(n). In case of using the additional field tail in the linked list, we can achieve O1 for the removal of an element from the end of the set, because in that case we do not have to iterate or traverse the linked list, that is storing the element behind the scene, and we can directly access the last node and remove it. Search is sequential or linear for unsorted sets. no matter whether we use array based implementation or a linked list based implementation. So runtime is O1 if the first element is the search element or the search key. Otherwise, we have to use ON complexity in case of average and worst case scenarios. In sorted array based set implementation, if we are implementing array sorted set using an array, we can utilize binary search, which is way faster than ON, and its complexity is O log n. But this binary search is very hard to implement in case of linked list based implementation. So it is only useful if we are utilizing array for the sorted set. Accessing the size of the set is O1 always, because we can directly return the number of elements stored within the set. And print function O1 if there is one element, ON otherwise. In best and worst cases, n is the number of elements stored within the set. So print has linear runtime, that is ON. Thank you guys. That is all. Let's start the code. And again, if you have not already subscribed the channel, please subscribe. Thank you. Hello guys. Let's implement linked list based sorted set. So I have created an application in NetBeans and added classes necessary to implement the sorted set based on a linked list. So I have a tester class to test the functionality of the sorted set, and a node class that we will use to implement the linked list, and the sorted set that will implement the linked list based sorted set. So let's begin with the node class. So this is our node class that will encapsulate a data and a reference to the next node. So we simply add the data fields, private int data, and add reference to next node, private node next. This data can be anything, and because this video is made to learn, so int is the very basic data type. You can implement it with any data, any class, anything that you like. So let's initialize the data field and the next reference. So let's pass the data into its constructor, int data, at param data to store. So this data is equal to data, and next reference will be null. Okay, we can simply create getter and setter methods. Right click, insert code, and select getter and setter. Select both the fields, click generate, and this will generate over getter and setter methods for the node class. This is a very simple entity class that you can use to implement a linked list. So we are going to use this list, this node class, to implement a sorted set based on a linked list. So I am not going to implement a linked list separately. I am going to implement the set based on the linked list. So everything will be within the sorted set class. So what we need, head of the set. So it will be a node, private node, and head, or front, whatever you want to say. So head is okay. So next we need to count the number of elements, count elements. So private int count. So the constructor will create the set, create an empty set at the startup, because there will be no element at the beginning of the set, at the time of creation of the set. This dot head is equal to null and count is equal to 0. Okay, next we need few functions to manage the data structure, and the other functions that will be particularly important for the set operations. For example, union, intersection, difference, complement, disjoint set, and proper subset. So let's begin with the data structure, basic functions. And next we will add set specific functions. Okay, let's begin with these. Let's define the prototype of functions we need. So public boolean add int data function to add new element to the sorted set. So conditions, number 1, uniqueness, no duplication allowed. Set is always contain unique elements. So next is maintain ascending order of the set, of the sorted set. So the set will maintain the elements in ascending order. Okay, so this is data to add, and return true if added, otherwise false. Okay, next we will implement this function shortly. Let's add the prototypes first. Public boolean remove int data. So this function will do the linear search, find the element, if found, remove it, return true or false based on success or failure. So data is equal to data to be removed, and return indicate success or failure. Okay, next we need a function, let's say private boolean and add front int data. This function will add new data element at the beginning of the set. Data to add, and return true if added, false otherwise. Okay, next we need a function to, let's say, size, int size. Okay, this function will give us the number of elements within the set. Okay, retrieve number of elements in the set. Normally in set notation it is like this. This is n. N is a function of that will return the number of elements. Return number of elements. Okay, next public int, not int, public boolean find int value. So this function to check the existence of an element within the set, value to return, or value to check, and return indicate exist or not, true or false. So next we will need public boolean is empty. So we return head is equal to null to indicate if the set is empty or not. Check if the set is empty or not. So return true if not empty, otherwise false. Next we are going to implement print function, public void print. function to print the sorted set. Okay, let's begin with this function. So if it is empty, output a message. If this dot is empty, s out, this sorted set is empty, and return from here. Okay, now if it is not empty, so what we will do, create a current node. Current is equal to head, print it, current dot get data, and move to next node, while current is equal to current dot get next. Now loop till the end of sorted set. So current is not equal to null. So we will print the value. Copy this and paste it here and change the output. So now move to next node till we reach the end of the linked list. So it will become current is equal to current dot get next. Okay, that's it. Now close the square bracket. So s out and close. This is our print function, and this will print values like 1, 2, 3, 4 and 5. This is the way it will output the set values. Okay, now find function. So to find the function, first check if empty. If this dot is empty, we return false. Otherwise we search. So to search, create the current node and assign head to it, loop till we find the element or reach end of the set. Okay guys, now we loop and iterate the set while current is not equal to null, and we check the value stored in the current node. If current dot get data is equal to value, we return true, and we move to next node to end the while loop. Move to next node. Current is equal to current dot get next. This is important step. Otherwise loop become infinite. And now we return false, not found. It means value does not exist within the set. Now let's do the size function. Size function is simple. We simply return count way. Okay, now add front function. So first check the existence. If not, find data. Otherwise return false. Means it already exists in the sorted set. So here we create node. Node is equal to new node. Okay, we check if empty. If the set is empty, pass the data to it. If this dot is empty, so we simply store the new node to the head node. Head is equal to node, and otherwise it means the set is not empty, so we will store it as the first node in the set. So how we will do it? We set the new node to the we set the head node to the next node of new node, and then assign it to the head. So node dot set next is equal to head, and head is equal to node. That's it. And we increase the count, and this is how we will insert in a sorted set. So if this condition is necessary because the set cannot contain a duplicate element, avoid duplicate element. Otherwise, if we are inserting into an ordinary list, we do not need the above condition, and we simply store it at the first node in the linked list. But this is a sorted set, so we have to check if there is a same value already exist in the set. So return true to indicate successfully inserted. Now this is let's implement the add function. Okay, check two condition: if empty or if data is smaller than the head node data. So we insert at the front of the sorted set. So these are the two situations. So first is if this is empty, if the set is empty, or data is less than head dot get data. So if the new data element is smaller than the data stored on the head, so we will add at the front of the sorted set. Otherwise, if the set is empty, so there is nothing in the set, so we have to store it on the head of the set. So we will call the add front function, this dot add front, and pass the data, and we return it. This function returns the successful operation or failure of operation in the form of false. Okay, now the condition is met. We reach here, insert the new data element at a correct location. So first we create new node. Node is equal to new node and pass data. Okay, now check if data already exists. We don't need to check here because add front function already doing it here. The add front function already checking for the duplicate. So we also have to handle the situation of duplication here. So if not find and data, we move into the if block. Otherwise, already exist, return false. Okay, here find the location. So we create current node is equal to head, and we navigate or traverse the sorted set to find the location. So how we will do that? We are looping while current dot get next. 1 minute. Okay, so we will check the next node is not equal to null, and we check the data stored there should be less than equal to the value. So current dot get data is less than equal to data. So if this is the case, we move to the next node. So current is equal to current dot get next. This way we will find the location. Either we reach at the end of the linked list, or we will find the location where we have to insert the new node to keep or to maintain the order of the linked list. So in this case, there are two cases. Case number one, we reached end of the sorted set, and case two is we have to insert somewhere between two nodes. So let's code it. So first we check if current dot get next is equal to null. This is case one. End of list. So we will insert at the end of the linked list base set. So current dot set next is equal to node. That's it. Okay, now else case 2, somewhere between the nodes. So in this case, we will set the next pointer of current node to the new, and the next pointer of new node to the current next node. So this is how we will do it. First we update next reference of new node to current's next reference. So node dot set next is equal to current dot get next. Okay, and otherwise next step we need to update the pointer of current node's next pointer. That should point to the new node now. Update reference of current node to new node. So current dot set next is equal to node. This is how we will insert between the two nodes. Okay, and update count plus plus. So this will keep track of the number of elements currently stored within the sorted set. Return true, and that's it. Let me check. Here we return status of insertion at the front of the list, and then we create the new node if we have to insert within the sorted set. Check if duplicate exists. If it does not exist, create new node and loop to find the exact location, and check the two situations: insert at the end of the sorted set or insert between two lists, and then increase the count. This is how we will implement and maintain the add function that will maintain the order of the ascending order of the elements. Now the remove function. Okay, the remove function, first check empty. If this dot is empty, we display output message as out this sorted set is empty, and we return from here because there is nothing to remove and no need to check anything else. Now we have non-empty set. So let's check case 1. Check the element stored at head node. Okay, if head dot get data is equal to data. So what we will do, store the next node to the head node. Get next, and let's count minus minus and return true. Okay, now the first node is not having the same data, so we have to remove somewhere between the sorted set nodes. So we to keep track of current node current is equal to head, and pre is equal to null. Okay, next we iterate while current is not equal to null. So we iterate till the end of the sorted set. Okay, let's now check if current node data matches. So we find a match that we have to remove. So if current dot get data is equal to value, so we remove the node from the sorted set. So to do that, we swap the next pointer of pre and current and skip the current so that it will be removed from it. So we set pre dot set next is equal to current dot get next. Okay, next we reduce the size and we return from here, return true. Okay, and here we update the navigation or traversal references. So we set the pre to current and current is equal to next node. This is how we implement remove function. Return true means data does not exist. Return false. Okay guys, this is how we implement the function, the remove function. So first condition empty, notify the user and return. And if the data exists at the front of the or in the first node of the set, remove it. Reduce size, return true. If data exists somewhere between the sorted set, use these two references to traverse the set till the end of the sorted set. If we find a match, update the next pointer of pre node to the next node of the current node. Reduce size, return true. Here, keep on the traversal to the next nodes, keep track of pre node and set the current to the next node. And if we reach here, return false. That means that value does not exist within the sorted set. So guys, now I am going to implement set related functions. So first function is union. Public sorted set union set other. Okay, so union of two sets A and B. So example, A is equal to 1, 2, 3, let's say 3 and 5, and B is equal to let's say 2, 4 and 6. So the A union B will be 1, 2, 3, 4, 5 and 6, because this is a sorted set, so it will maintain the order. Return, let's add one more element, 7 for example, and 7 comes here, and if we also have 2 here, so this 2 and this 2 is common in A and B, but it will only occur once in the union. So parameter other set and return the union of two sets. Okay, next public sorted set intersection sorted set other. So this function create the intersection of two given sets. So example, let's say set A is equal to 1, 2, 3 and 5, and set B is equal to 2, 4 and let's say and 5 and 7. Okay, now A intersection set is equal to 2 is common, we take it, 3 is not common, skip it, 1 is not common, skip it, and then we have 5 in common. So the resulting set will be 2 and 5. Other set, return intersection of two sets. Okay, next, set difference. Public sorted set difference. Set other. Okay, function to create the difference of two given sets. So its example is like A is equal to 1, 2, 3, 4 and 5, and B is equal to 2 and 4. So the difference will be 1, 3 and 5. This is a super universal set and this is another set. So 2 and 4 are common. So difference will be all the elements of A that are not in B. Other set and return the difference of two sets. Okay, next function is public sorted set, and let's say complement sorted set other. Complement works with the universal set. There is a difference between two sets and a universal set. A universal set is the superset that contains all the elements of its subsets. So the complement will be all the elements of universal set that are not in a particular set. So compute the complement set of A, that is A, and it is read A prime. So U is equal to, U is a universal set. So 1, 2, 3, 4, 5, 6, 7. And A is equal to, let's say, 2, 3 and 6. A prime will be, A prime means the complement of A. Complement of A is all the elements of universal set that are not within the set A. So 1 is not in A, so it is in A prime. 2 is in A, we skip it. 3 is in A, we skip it. 4 is not in A, so 4 will come in A prime. And 5 is not in A, so 5 comes in A prime. And 7 is also there. So there is a check also. There are various properties. For example, NA plus NA prime is equal to NU. The number of elements in A and the number of elements in A prime are equal to the number of elements in universal set. Okay, this is kind of set theory in mathematics. Other set, and return the complement of A, that is A prime. Okay, next function is public boolean is disjoint set, let's say other. Okay, this function will check if the two given sets are disjoint. Disjoint property. Two sets are disjoint if there is no common element exist within those two sets. Example, let's say A is equal to 1, 3 and 5 and B is equal to 2, 4 and 6. So these are disjoint sets. Other set and return true if both are disjoint, otherwise false. Okay, next function is public boolean is proper subset. So sorted set other. Okay, what is a proper subset? Proper subset is a set that contains all the elements, that has all the elements from another set. So function to check the two sets. If one set is proper subset of other set. Example, let's say we have A is equal to 1, 2, 3, 4 and 5 and B is equal to 2 and 4. So set is always referred by capital letter. So B is a proper subset of A because both the elements of B exist within A. Okay, so let's implement these functions. To check if other set is a proper subset of the current set, so we loop for the other set. For int I0, I is less than other dot size I plus plus, and we check if ith element of other exists within current set. So if find other dot data, sorry, we have a linked list, sorry, let me iterate. So we start with the current node current is equal to other dot head. So while current is not equal to null, so what we will do, check existence in the current. Start with first node, loop at the till the end of other set, check if element exists. If not, return false. If not, find current dot get data. So we return false because this element does not exist in the current set. To be a proper subset, all the elements must exist within the current set. So navigate current is equal to current dot get next. And if we reach at the end of the function, return true, means all the elements of other set exist within the current set. So it is a proper subset. Now the disjoint set. So disjoint set, we loop current set. So we loop for the current set and check if any element is common between the two sets. It is not, they are not disjoint sets. So start with current node and loop while current is not equal to null. So we check if other dot find current dot get data. So if any find function return true, it means they are not disjoint. So we return false. And navigate to the next node, get next. And here they are not, they are disjoint sets. So we return true. Now next function, complement function. So complement function, we need to iterate the universal set, and if any element exists within the other set, we skip it, and if it does not exist, we add it to the new set. So create new set, sorted set, let's say set is equal to new sorted set. So start with the first node of current set, that is universal. Okay, so node current is equal to head and loop till end of universal set. So while current is not equal to null, so we check if element in other set. If not, other dot find current dot get data. So if it does not exist within the other set, so it is part of the A prime. So set dot add current dot get data, and we move to the next node. Current is equal to current dot get next. This is how we create a complement of a set, and we return the set. It's complement of a set other. Okay, now the difference work, we iterate every element of current set, that is A, and if the element exists within the other set, let's say it's called B, we skip it, and if it does not exist, we add it to the different set. So create new set, sorted set is equal to new sorted set. Okay, start from the beginning of current set. So node current is equal to head, loop till end of current set. So while current is not equal to null, we check if element does not exist within other set, we add it to the new set. So if not, other dot find current dot get data, add it to the new set. Set dot add current dot get data. Okay, move to next node. So current is equal to current dot get next, and this is over different set. So we return it, return set difference A minus B. Okay guys, now over intersection function. So intersection function, okay, we can copy this and we only change the if condition and we will create intersection. Okay, here we created a new set and we start with the first node of current set, then we loop till the end of the first set, and we check if the element exists in the other set. If element exists in the other set, it means it is a common element between both. So common element we will add to the intersection set, and we move to the next node and return the node, and this is intersection of two sets that contains all the common elements of both the sets. Okay guys, now union set. So union is little different. We have to add every element, but we must keep track of all the elements must be unique. So this uniqueness is maintained within the add function. So we do not have to bother about the duplication. So we will do create new set. We loop every element from current set and add it. New set. So node current is equal to head and loop till the end of it. Current is not equal to null, and we directly add it to the set.add current.get data, and we move to the next node, current.get next. Okay, that's it. Now we can copy this and iterate the second set. Okay, iterate other set, that is the parameter set, and add all the elements to new set. Okay, now just change it other dot head because we are iterating other set, and that's it. Nothing else to do. This will start with the first node in the other set and it iterate till the end of the other set and add the element to the new set, move to the next node, and we return the set. This is union of two sets. The add function automatically maintain the order and also maintain the uniqueness of elements. That is all guys for the set functions. Now let's test the functionality of sorted set. So we begin with create couple of sets to test. So set. So let's create some sets. Sorted set U. This is our universal set. New sorted set, and two more sets. Set A new sorted set and sorted set B. New sorted set. So let's add few elements. Okay, add u dot add, let's say 1. Two, 3, 4, 5, 6, let's say 2, 3 and 4 and 5 and 6, and let's say 7. Now a dot add 1, let's say 3 and 4. Let's add one more, 6. Now b dot add and 2, 3, 5 and 6. Okay. Two, 3 and 5 and 6. Okay, now let's print to check the state sets. So u dot print, a dot print and b dot print. Let's run it. Okay, these are our sets. So order is maintained. So we have these elements within our A and B sets. So now first function, union, test union, test intersection, test difference, and test complement and test disjoint and test proper subset. Okay guys, let's begin with this one. So set is equal to A dot union B, and let's print union of A and B, sorted set. Okay, set dot print. Let's check it. Okay, so these are our A and B sets 1, 3, 4 and 6, 2, 3 and 5 and 6, and all these elements are within the union of the A and B, but there is no duplicate, and the order is also maintained. That is how we implement sorted set and its union function. Okay, next we can copy this to save over time, and we make it intersection. Okay, now this is intersection, so let's check it. So this is how intersection works. 3 is common, 6 is common, and intersection of A and B return the new set, that contains the common elements of A and B. Now the set difference. Same way we copy this. Okay, A difference B, difference of A and B, that is A minus B. So let's test it. Okay guys, so difference of A and B is all the elements of A that are not in B will be the difference of A and B. So 1 is in A but not in B, we have 1 here. Same way 4 is in A but it is not in B, so we have it here. This is how the difference of sets work. Okay, next we need to test the complement. So let's copy this again, paste it here and change the A to U, because we are testing the complement. This is complement of A. Complement of A, that is A prime. Okay, and again we call it with B, so complement of B, that is B prime. This is all the elements of universal set that are not in A. All the elements of universal set that are not in B, these are the A prime and B prime functions or set, the complement set. Okay, now let's check it. So this is our universal set. So complement of A is 2, 5 and 7. So A does not have 2, so it is in the A prime, and 5 is not in A, so 5 comes in the A prime. Then 7 is not there, so 7 is in the A prime. So this is complement of A, that is read as A prime. Similarly, B prime, all the elements from universal set that are not in B comes in the B prime. Okay guys, now the disjoint sets. Okay, S out. Is set A and B disjoint. A dot is disjoint B, so they are not disjoint. Similarly, let's test is proper. Is set A proper subset of U? Obviously, any set is a proper subset of universal set. So U dot is proper subset A. B is also proper subset of universal set. So B, but A is not proper subset of B. Is A proper subset of B? No, it is not. Similarly, B is not proper subset of A. So B and A. Is B proper subset of A? No, it is not. So let's run and check. Okay. So A and B are disjoint? No, they are not disjoint because they have common elements. 3 is common and 6 is common. Let's make another set for the test of disjoint. Sorted set C is equal to new sorted set, and let's add couple of elements. C dot add, let's say 9. C dot add, let's say 11, because these elements are not in A and B, so we can test for the disjoint. Okay, is A and C, is B and C disjoint? So A and C and B and C. So these should be disjoint. Okay, so first A and B are disjoint? No, because they have common elements. But A and C and B and C are disjoint because they have no common element. Similarly, is A proper subset of U? Yes, it is. Is set B proper subset of U? Yes, it is. But A is not subset of B and B is not subset of A. So both are false. That is all, guys, for today's tutorial. This is a lengthy video, almost an hour, and I have covered all the important topics about sorted set and implemented basic functions and the set theory functions for the sorted set. And I hope you have learned a lot from this video. And if you have any question to ask, you can comment and I will guide you or help you sort out your problems. And if you have not already subscribed to my channel, please subscribe and promote the content. Thank you guys. Have a very good day and see you in the next video.